Hey kiddos, in your notebooks you can go ahead and label in the top left hand corner or annotate 6.5. This is unit 6.5 in regards to angles. And just as a quick reminder, as we're about to go through today's lesson, acute angles are angles that are less than 90 degrees, which you can see with the red line segment that forms an angle. And then obtuse angles are angles that are greater than 90 degrees, which you can see is formed with that second line segment that is green. Just want to keep those two things in mind because today we're going to be creating or drawing or measuring triangles. And we want to just remember that when we're looking at the different parts of a triangle, that the measures of the different angles, we want to make sure that we understand, hey, even before we take out our protractor and start to measure, we should be able to see or be able to tell whether or not a particular angle is obtuse, whether a particular angle is a right angle like we see here, whether or not a particular angle like we see at this one, if we were looking at this angle, if it's greater than 90 degrees, or if we see something like this, if it's less than 90 degrees. And so even before we get the exact, because we're going to be using our protractors to measure angles as well as measuring the side lengths of these triangles, we should be able to make an estimate and see whether or not that estimate is reasonable or not. So let's take a look at the first example. If we take a look at the front of our packet, we have our think about it, and the aim for today is being able to define the conditions needed to construct a triangle. And so we're going to go ahead and measure and label the angles as well as the side lengths of the two triangles that are below. And so go ahead and with your protractor, we're taking a look at the following. So let's first start with the angles. Go ahead and measure each of the angles of measure angle A, angle B, and angle C. In step A, it asks us, what do you notice about the sum of the angles for angle A, B, and C for that triangle, and the sum of the angles of D, E, and F? What do you notice for both of them? What is the sum? I'm hoping that you notice that the sum of the angles for both of these triangles is 180 degrees. Sum of the angles is 180 degrees. There should only be two E's there, my bad. So for every single triangle that is drawn, it's going to be 180 degrees. Now, if you were a kiddo that measured the angles incorrectly, if you're off by 1 or 2 degrees, that's okay. That's all right. It should be 180 degrees, but I understand that with protractors as well as looking at the printed page, that the angles might be off just a little bit. But the measures should come up to 180 degrees. Every single triangle, when you add up the sum of the angles, it should be equal to 180 degrees. And then what does it say for step B? Step B says, explain what you notice about the sum of the shorter sides. So once you've measured all three sides of the triangles, and you compare looking at the two shortest sides compared to the longest sides, what do you recognize? Well, hopefully you're recognizing that the sum of the shortest sides of the triangle is greater than the longest side. And this makes sense because if the two shortest sides didn't add up to more than the longer side, then the sides couldn't connect to create a triangle. So for example, if the measurements were 2, 3, and 8, even if you laid out the sides of the measures of 2 and 3 in a straight line, you couldn't connect it to the endpoint of the side that was measuring 8. So we recognize that the sum of the two shortest sides has to be longer than, or has to be greater than, than the longest side. So there are two things that we're going to be really looking at today. Those two things are, one, the sum of the angles of a triangle must be 180 degrees. And the sum of the shorter sides must be greater than the longest side. So with these two things in mind, we're going to want to make sure that whenever we're measuring a triangle, we know that the angles are going to add up to 180 degrees, and that the two shortest sides of that triangle must be longer or greater than the longer side. All right, let's take a look at our conjecture. We have the following measurements. Which set of measurements could be used to create a triangle? We're looking at triangle ABC with the angles of A being 45, B being 80 degrees, and C being 70 degrees, or triangle XYZ with angles X being 45 degrees, angle Y being 45 degrees, and angle Z being 45 degrees. Well, let's take a look at what do we know. We know that angles have to be equal to, or the triangle has angles that total to 180 degrees, and then the sum of the two sides, the two shortest sides, has to be greater than the longest side. All right, so these are short side 1, short side number 2, and then the longest side. We'll say that's side number 3, which is the longest side. All right, let's take a look at our angles first. So for ABC, A is equal to 45, B is equal to 80, and C is equal to 70. When we add this up, 5, 15, and 4, that's 19, 195 degrees. Is that 180? The answer is no. So that means triangle ABC, that's impossible. That cannot be created. What about XYZ? XYZ, X is equal to 45 degrees, Y is equal to 45 degrees, and Z is equal to 90 degrees. 45 and 45 is 90, 90 and 90 is 180. That works. So triangle ABC is not possible. So that's it. That's an X. Whereas triangle XYZ, that is possible. We can actually create that triangle. We also see that, hey, the sum of the two shortest sides, 45 and 45, we see that it's equal to actually 90 degrees. So we can recognize that this is a right angle. This is 45 degrees and this is 45 degrees. That's actually possible to create. Whereas our two shortest sides here were 45 and 70. Those were equal to 115 degrees, which is greater than the longest side here, which was 80 degrees. However, because it didn't add up to 180 degrees, that's why this triangle is not possible to create. Let's take a look at tested conjecture number 2. Which set of measurements could be used to create a triangle? Once again, remembering, let's go ahead and erase all this extra. Remembering our two main points for today, two key ideas, is that our angles have to be equal to 180 degrees, and then the two shortest sides have to be greater than or equal to, just like we saw with that right angle, greater than or equal to the longer side. So first off, triangle ABC. It says AB is equal to 2 inches. BC is equal to 3 inches. Let's just erase that. We'll put A over here, B over there. So BC is equal to 3 inches. And then CA It's equal to 4 inches. So when we look at the 3 sides, we're looking at our 2 smaller sides. Is that greater than the longest side? The answer is yes. That's possible. What about XYZ? We'll go ahead and erase this. XYZ, what do we know about triangle XYZ? It says that XY is equal to 4 inches. So XY is 4 inches. YZ is equal to 2 inches. And then ZX is equal to 1 inch. Well, right there, excuse me, right there, I know that if this is 2 inches, this is 4 inches, and this is just 1 inch, yowzers, that is not possible. We're not going to be able to create a long enough side for this triangle for it to be able to connect, so that's going to be a no. And then what about the last one? QRS. QR is equal to 3 inches. RS is equal to 6 inches. And then SQ is equal to 3 inches as well. So this is going to be here. Is that possible? Well, just like we saw in our last one, because these two are equal to the longest side, this is possible. This would create a oh no, this wouldn't be possible. If SQ were the longest side, then that would be possible. But because it's SR, that's why it's not possible, or RS. That makes it not possible. So based off of what we know, the only triangle that would be able to be created is the first triangle based off of it having the properties of both 180 degrees or the sum of the two sides is greater than the longest side. Alrighty, let's take a look at our partner practice today. First one that we'll do together before you move on to partner practice with your teammates. It says measure the angles of the triangle below and then verify that it satisfies the conditions that the sum of the angles must be 180 degrees. So we just got to take out our protractors, measure the angles of, we'll call this A, we'll call this B and C. And let's see, does this create or will this have a sum of 180 degrees? Let's find out. Go ahead and pull out your protractors and let's go to work.